Hi everyone, welcome to this video lesson. So in this lesson, we are going to review operations with fractions. Operations such as adding and subtracting fractions, multiplying fractions, and dividing fractions. Okay, so this knowledge is already in your toolbox. So we're just going to review in case you feel like you don't remember, but you have seen it before. So in order to add or subtract fractions, the fractions have to have a common denominator. Okay, so if that is not the case, then you must find that first. So for example, what would be the common denominator of 2 and 5? Because this has a 2 in the denominator, this has a 5. And that means since they don't have the same denominator, we cannot do the operation of addition with these two fractions. So then you can try the following. What I'm going to do is I'm going to multiply 2 times 5, and that gives me a 10. And as you can see, this denominator will be 10, and this denominator will be 10. So that means we'll have the same denominator. So let's proceed. Let's go ahead and do that. Okay. So multiply to make this to a 10, multiply that by 5 over 5. And I hope you're seeing what I'm doing here. What I'm doing is I'm manipulating the number 1 in such a way that it helps me get a 10. Okay, so in algebra, the number 1 is very important. Why am I saying the number 1? Because if you think 5 divided by 5 is 1, right? So that's number 1. Okay, so the second fraction, it has a 5 in the denominator. I need a 10, so then I need to multiply that 5 by a 2. So I need to do that to the numerator and to the denominator. So then when I multiply 5 times 1, that gives me 5, and 5 times 2 gives me a 10, plus 3 times 5, that's a 6. 5 times 2, that's a 10. So now as you can see, we have common denominators or denominator. So then we just proceed by adding the numerators. So I'm going to add 5 plus 6, which is equal to 11, and then the same denominator. So notice I am not adding the denominators, only add the numerators. Okay. Now 11 and 10 do not have any factors in common, so that means we can't simplify this any further. So this is my final answer for this problem. All right, so let's proceed to number 2. Example number 2, I have 1/12 or 1 over 12 plus 3 over 4. Well, this is 12 and this is 4, which means we do not have a common denominator, so we need to find that first. So I have a 12 already, and I also notice that 4 goes into 12 evenly, right? Since that's the case, then I need to turn this into a 12. So I'm going to use the number 1 to help me get a 12 or have a 12 in the denominator. So to be able to do that, I have to use the number 1 by writing it as 3 over 3, because when I multiply 3 times 4, that gives me a 12. So then the first fraction stays the same, 1 over 12 plus, and I wrote here something else, 1 over 12 plus, and then 3 times 3, that's a 9, and 4 times 3, that's a 12, and this is what we wanted. We have the same denominator. So then add the numerator. So 1 plus 9 gives us a 10, and then 10 over 12. Now notice, these two numbers are not prime, they're composite numbers. So what I'm going to do is I'm going to decompose the numerators, the numerator into by multiplying two prime numbers, which are 2 times 5. All right, and then 12 is the same as 2 times 6. So I could decompose 6 into 3 times 2, but the only one they have in common is the 2. So notice this 2 over 2 becomes a 1. So in the end, all that's left is 5 over 6. And I'm just using prime factors decomposition. Or you could also just think of it, okay, what number goes into 10? That also goes into 12. That's the number 2. So then 10 divided by 2 is 5, and 2 divided by 2 is 6. This cannot be simplified any further. So this will be our final answer for that example. Okay, example number 3. For this one, we're subtracting these two fractions. This is 7, this is 8. We don't have a common denominator. So what I can think of right away is, what if I multiply 7 by 8? Or 8 by 7. So that will give me a 56. So the common denominator will be 56. So I multiply by 8 over 8. Again, I'm using the number 1. And this one, multiply 8 times 7. This one is an 8, so I'm going to multiply that by 7 over 7. Okay, so 8 times 2 is 16, and 8 times 7 is 56. Minus 3 times 7, that's a 21. 8 times 7, that's a 56. Okay, then I'm going to subtract 16 from 21. Notice the minus means the 20 implies the number 21 is negative. So this is 16 minus 21, which is negative 5, and then keep the 56 in the denominator. And 5 does not go into 56 evenly. That means we are done with this problem. Okay. Example number 4. This is 3 minus 4 thirds, or 4 over 3. This 3 is implied to be over 1. So don't forget, rational numbers can be written as fractions, or if it's a whole number, this is implied to be 3 over 1, which makes it a fraction or rational number. Okay. All right. So fractions are rational numbers, by the way. So then I need to have a 3 in this denominator. So that means I multiply by 1 by writing it as 3 over 3. So then 3 times 3 is 9. 3 times 1 is 3 minus 4 over 3. Now we have common denominators of 3. So then just subtract 4 from 9. So 9 minus 4 is 5. And we have the same denominator. 5 is prime, 3 is prime. This cannot be simplified any further because 5 and 3 are prime. They have no factors in common by definition of prime numbers. So that's the answer to that one. Okay, multiplication of fractions or rational numbers. Multiply straight across. That means tops with tops, or numerators with denominators, and bottom with bottom, which is denominators. Okay. Reduce diagonally or up and down. So always look to see if you can reduce. If you can reduce right away, then that'll make the problem simpler to do. Okay, because if you just multiply top with top and bottom with bottom, you might end up with a large number that's going to be a challenge, or it's going to take more work to simplify. So with that said, I'm going to look at diagonally first for this one. The 3 and 5 have any multiples in common? In other words, is there a number that goes into 3 that also goes into 5? The answer is no. Okay. 7 and 14. Well, does 7 go into 14 evenly? It does, right? How many times? If you thought 2, then let's cross out the 14, make it a 2. And 7 goes into 7 one time, so cross out that 7, make it a 1. Now we multiply top with top, so 1 times 5. And bottom with bottom, 3 times 2. And 5 and 6 do not have any multiples in common. This is the simplest way we can write this answer. Okay. All right. Example number 2. Same thing. Does 11 go into 7 evenly? The answer is no. They do not have any multiples in common because 11 is prime and 7 is prime. Do 8 and 24 have any multiples in common? Yeah. 3 goes into, well, actually no. 8 goes into 24 evenly. How many times? So what's 24 divided by 8? If you said 3, you are correct. And then 8 goes into 8 one time. So cross out the 8, make it a 1. Now multiply across top and across bottom. So 1 times 7 is equal to 7. And 11 times 3, that's equal to 33. Then these two are, 33 is not prime, but you can't simplify them at all because 7 does not go into 33 evenly. So this is our final answer for this example. So now let's go for division of rational numbers or fractions. So notice, when you do division of fractions, you multiply by the reciprocal of the second fraction. Don't forget, they are rational numbers. Okay, so even if you see a whole number, that whole number is implied to have a 1 under it. So you can write a whole number as a rational number or as a fraction. So with that said, the first example, this is implied to be 7 over 1. Then I'm going to rewrite or write this as it is. So 3 over 8 stays the same. Then I'm going to change division to multiplication, and I'm going to multiply by the reciprocal of 7 over 1, which is 1 over 7. So now I just do what I did on part 2, multiply across tops and across bottoms. And I can try to see diagonally if something simplifies, but right away you can see that there's nothing that simplifies because 3 and 7 are prime, 8 and 1. So just multiply cross top. So 3 times 1 is 3. 8 times 7, that's 56. And this cannot be reduced. So this will be our final answer. Second example for division. So then what I'm going to do here, maybe, I don't know if you see it, maybe I should go back and do it here. So what I'm going to do is I'm going to rewrite this as 3 over 8 divided by, this is 7 over 1, right? So I just reciprocate. So I'm going to do that here. I'm going to rewrite it, and that might help you see it. Maybe will make it easier for you. So 4 over 9 divided by 1 over 5. So what I'm going to do is I'm going to keep this fraction the same. So 4 over 9, and then change division to multiplication, take the reciprocal of this, which is 5 over 1. And then multiply across and across bottom, and then check if something simplifies. But in this case, nothing simplifies. So then this is equal to 4 times 5, which is 20, and 9 times 1, which is 9. Something that you learned when you were introduced to dividing fractions was the keep, change, and flip, KCF, right? So if you remember it that way, that's fine. Keep, change, and flip. So keep the first fraction, change the division sign to multiplication, and then flip the second fraction. That's all for this lesson. I'll see you in class. Bye-bye.